Hi, everybody, and welcome back to the EBI Seminar Series. This episode, we're going to be speaking with David Zilberman, who is a professor at UC Berkeley of Agriculture and Resource Economics. He is going to be introducing us to the idea of the bioeconomy at large and its smaller parts. Thank you for watching and enjoy. Professor Zilberman, thank you for joining us today. How are you?
Oh, I'm fine. It's really a pleasure to join you.
Oh, it's a pleasure to have you join us. Okay, so we're going to be talking about the bioeconomy and basically explaining what that is. So, for our first question, can you explain what the bioeconomy is at large and what are its smaller categories?
Okay. The bioeconomy is a combination of sectors of the bioeconomy, of the economy, part of the economy that is relying on natural resources, on water, soil, land, and modern technologies, biotech, information technologies, chemistry, to produce a lot of products, including food, fuel, chemicals, environmental services, sequestration of carbon. The basic idea of the bioeconomy is that when we use our technology, we can use in agriculture much more than we can produce in agriculture, much more than food. You can produce fuel, you can produce other things. Now, the basic rationale for it is that a lot of the solution to climate change, like solar energy, wind power, all this other stuff, are very good, but they may not be able to do it and to do enough. On the other hand, the bioeconomy can do it. Now, there are many, many parts of the bioeconomy. One part of the bioeconomy is what I call the green bioeconomy. Basically, trees, land, agriculture, all the sectors that are really using the land, including forest, agriculture, range. That's part of the bioeconomy, and you can do a lot. If you increase the productivity of agriculture, which can be done, you can double or triple the amount of output that you can produce. So if you can increase productivity, let's say by 30%, you will get 30% of the land and you can do a lot of stuff with it. Then you have what one can call the blue bioeconomy, which is a mystery. This is the water. You have lakes, rivers, and the oceans. And you can have fish, algae, every other seafood that you can have. And the ocean is big and you know very little about it, but you know that the ocean can sequester carbon, the ocean has a lot of mineral, and it can be another source of production of food. It will be more than fish. Then you have what I call the brown bioeconomy, the reuse, because the key element in the bioeconomy is circularity. You can reuse material, you can basically save save a lot of waste, you can reuse a lot of residue, and it can be used to produce a lot of stuff. Like we have about, I don't know, 30 to 40% of our food is residue. Either it's not grown in the field or not harvested in the field, or a lot of time we don't want to eat. Not eating food is a lot of time is actually good because sometimes we eat too much. So what do you do with all of it? So you can use it, you can transfer it with through black soldier fly, you can transfer it to be to produce protein. You can use it as a food stock, a feedstock for many many activities. Then you have the microbial bioeconomy that you use all the microbes and the microbiome and a lot of other elements to produce new food, medicine, etc. Then you have what I call the white bioeconomy, which is basically biomanufacturing. You can produce food and other stuff using new technologies, using biotech, using plants. You can produce vaccines with plants. Think about it. The pandemic would have been solved because of the basically because of this type of manufacturing. Then there is a huge potential of the bioeconomy in sequestration of carbon, both in basically sequestering carbon and then storing it. So there are many uses that one can develop, and they are a huge challenge to the university.
So, because the IBMC is focusing on seaweed, why do you think seaweed is a key player in the blue economy?
I've been working on seaweed for a long time. We know very, very little about seaweed. We know really, really little about. There are about, I don't know, 4,000 type of seaweeds. We can basically use 10. And seaweed has a lot of good properties. First of all, it doesn't have lignin. So we can much easier you can convert it to biofuel. You can use seaweed to produce protein. I have some papers. We look how we can use seaweed to produce sugar and protein. You can use seaweed to produce different type of food. So today the seaweed industry is small, $10 billion, but it can be much, much bigger. And it can produce a lot of chemicals. To me, the seaweed area is an adventure because because we don't know a lot about it. It's exactly what university need. We need to take this opportunity and through identifying all the species, identify what they do, identify their genomic, we can use them. Now, one thing for sure that seaweed can be used is to sequester carbon because a lot of carbon can be accumulated in seaweed and can be stored in the ocean. How to do it is a big scientific challenge, and that's what Berkeley can do.
Kind of going off of that, talking about carbon sequestration, what are the technologies of climate smart agriculture that can be applied to seaweed aquaculture?
I was one of the people that came with the term climate smart agriculture. And the basic idea of this term is that you develop new agricultural practices that can deal with climate change and also develop a result in economic growth. But there are many, many. I think the use of GMO or CRISPR or others can be very effective to develop high productivity and sequestering varieties. And the same thing can be done with seaweed. By the genetic engineering, you may engineer new type of plants that can do a lot of stuff. They can produce medicine. They can produce chemical. But we really need to know more about plants. So the gene editing now provides us incredible capability, and it's only the beginning. I think our understanding of genomic and the genetic process is only started. So I expect that in the future you can use a lot of algae for a lot of things that people don't use it today. I see every plant as a vehicle, and you can put in this vehicle a lot of different type of product. And as I said before, you can grow it in the ocean, and it can be served in multiple purposes. So to me, it's not the climate smart agriculture and seaweed complement one another.
Can you give us a quick overview of how the supply chain of seaweed currently works?
There are two types of seaweed. Some seaweed is harvested in the ocean, some seaweed is grown in ponds. But mostly for the people of harvest it in the ocean, it comes to factories, they basically process it, and they produce material. It can be agar-agar, which is in lab, and it may be some material that people use to produce, that can use, for example, fish ice cream, and there are other products. So it's relatively, you harvest it, you process it, you sell it. That's the supply chain. In developing countries, the harvesting will be done more in a manual level, and you may produce a different type of product. You may produce in some countries, you produce the seaweed is part of the diet. So I wrote several papers I wrote one big paper that basically look at what are the challenges. What I found that the biggest problem is how to increase the productivity of seaweed. Now, there are different supply chains. Some supply chains start in the ocean, other supply chains start in a pond. In the ocean, in many ways, it's cheaper. You don't need to have land to take land, but productivity is lower. And you have to deal with waves, and we need to deal with the problem of the ocean. In a pond, you have more safe environment, but the land is expensive. Different countries, different products, they will be different. So it's a new adventure, and you can look at different dimensions. And we don't really have a lot of scholars that work on it. I am fortunate to have to have one guy. His name is Dr. Goldberg, who is really good in stuff like this. But we need to have many, many people that really understand the challenge of growing seaweed, the challenge of processing seaweed, the talent of identifying what are the components of seeding, and it's multidisciplinary. So you need to have chemists, you need to have, I don't know, agronomists that basically, uh, instead of agronomists, it can be seaweed grower. We need to have people that are doing that understand more the marketing. And so it's a big challenge.
Obviously, there are a lot of considerations to account for, but when it comes to policies, do you know of any ways in which policies can influence seaweed acceptance and its potential for making the US a key player in the bioeconomy?
The US is a key player in everything. That's not. Now, the one policy, if seaweed sequester carbon, you need to get money for carbon that you sequester. That's one type of policy. We don't have a price for carbon. So that's number one. We have some good policies that if you can produce biofuel from seaweed, you can get a subsidy from or you can be part of the low carbon fuel standard, which is a policy we have in California. I think also need to have research and development subsidy or investment in research and development in seaweed. I think really now there is very little in seaweed. Like I think Berkeley need to have, I don't know, 5 or 6 faculty members that work on seaweed research. We have a center, but we need to have more scientists working for it. I'm an economist, so I can count, but I cannot grow seaweed. We need to have experts on seaweed. We need to have graduate students that work on seaweed. We need to have maybe an investment in some ponds near the ocean that can grow seaweed. So you need support for research, right pricing for product, and maybe some subsidization of the industry.
Perfect. Well, hopefully those are all topics we can hit on future episodes in this series, but that does it for all my questions. Thank you for kind of explaining what the bioeconomy is and how many factors there are and all these things that we need to consider. This was a really good conversation, so we thank you for joining us.
Thank you. Okay, bye-bye.
Thank you for checking out the EBI seminar series on the bioeconomy and the seaweed supply chain. If you've enjoyed this video, please feel free to like and subscribe to our channel for more content on the macroalgae bioeconomy. Be sure to follow along for future installments or check out our previous series and explore our social media, which are all linked in the description below. Thank you for watching and see you next time.